I welcome you all for my mathematics class. I'm continuing with the problems in Fourier transforms. This is my lecture 2 in Fourier transforms. Here I am going to explain I have already explained the modulation property in the case of a Fourier transform. Today I have taken one more property in this. Together with that I will solve one problem in Fourier transform. In the coming days I will explain what is the meaning of Fourier cosine transform, Fourier sine transform, and also the properties involved in the Fourier transforms. Okay, now here we have got here, so this property let me prove. What is this property? You are asked to prove that f of ax is equal to 1 by a into f of s by a. See, these are the properties which are very much essential, because while solving problems you may come across a situation where these properties must be applied. And also in university examinations for the engineering students, these properties, some of the properties will definitely be asked in part A questions, and some of the properties are very important and they may sometimes ask in part B also. So with that in mind, I am taking up this property so that the students will benefit from my teaching. Okay, now so you see that here it is very simple and straightforward. What is that? We know that the Fourier transform, the Fourier transform of f of x is given by, see, unlike this function f of x defined in certain intervals for Fourier series, here it is defined over minus infinity to plus infinity. So you see that here this f of x, so this Fourier transforms will come for the function f of x throughout the line minus infinity to plus infinity. So this is given by, how do you give this? This is f of x. This is the meaning of telling that you are taking the Fourier transform of f of x, and this is written by f of s, because when you go to the other plane, when you take the Fourier transform and you pass on to the other plane, it will be purely in function of s. So you see that this f of s, and this will be equal to 1 by square root of 2 pi. It is minus infinity to plus infinity. It is f of x into e to the power of isx into dx. And I told you in my first lecture class that this is not unique. Sometimes this will not be there, and you may have even 2 by square root of pi f of x into e to the power of minus isx, and for the inverse Fourier transform you will have it as minus sx. So like that, this Fourier transform is not unique, but for all said and done they represent the same, no difference, but you stick on to one form of representation of a Fourier transform. So this is the way I am practicing, I am teaching you, you can follow this. So this is now, so you see that take f of x is equal to f of ax. So you take this f of x as what? F of ax. Then what is that you get here? F of ax is equal to, so this is nothing but what? This is nothing but your f of s only. We will find what is this f of s. I will find out what will be my f of s. So this will be equal to 1 by square root of 2 pi minus infinity to plus infinity. It is f of ax e to the power of isx into dx. I have not done anything except applying this in the place of f of x. I put f of ax. Then I'll put here. So let ax is equal to t. You take this ax is equal to t. So you see that when x is equal to infinity minus infinity, t is also equal to minus infinity. When x is equal to plus infinity, t is also equal to plus infinity. And x is equal to t by a and dx is equal to 1 by a into dt. So I go for a substitution like let ax is equal to t, because of which you get this. If x is equal to minus infinity, your t will also be taking to minus infinity, and if you take x is equal to infinity, t will also tend to infinity, and that if you take dx will be equal to 1 by a into dt. So what is that you will get now? So substitute here. So 1 by 2 pi minus infinity to plus infinity. This is f of t into e to the power of I. In the place of x, you can write t by a. So s t by a into 1 by a into dt. So this will be equal to what? 1 by 2 pi into minus infinity to plus infinity. Take this 1 by a outside and put everything inside. This is f of t into e to the power of I s by a into t into dt. So I rearrange them in this way. So what is that you find? Just make a comparison of this. If f of x is equal to f of s, which is defined like this, if it is yes, you get here f of s. So you just compare these two, identify in the same way, and try to express this in term as a function of s. So what is that you get? If it is f of x, f of s, so here your e to the power of I, yes, so you put here. But in this place, can you see this here? It is s by a. So this is 1 by a. So keep that 1 by a. But this is a Fourier transform. This itself is your f of s. But in the place of s, you have got s by a. So this is nothing but f of s by a. So this is the answer. So this is the answer for you. And the second one is you yourself can say what is that you will do. So if you put 1 by a, wherever this a comes, you put as 1 by a. So if you give this 1 by a, so what will happen here? Suppose if you want here 1 by a, then it will become as what? This I leave it as an exercise for you. Use the same line, similarly go by the same method, you will get the answer. So this is how, this is called your change of scale property. This is the one. I have done this. Go and try this one. Try to do this one. This is a simpler one. You use the same method, you will get the answer. Okay. So this is all about the first problem. So this is over. So I completed that. This is your homework. This is your homework that you should try. Self trial is best. Okay. Now let me go to the next one. So I'll prove this. I'll come to the problem here now. So in this problem, what is given to you is, you're given, so this is over. This problem is over. So this is what we have. Now here you see that, let me straight away go to the problem, solving the problem. You see that you are asked to find the Fourier transform, And what is your Fourier transform? We know that f of x is equal to f of s is equal to 1 by square root of 2 pi minus infinity to plus infinity. It is f of x e to the power of isx dx. So this is what we have. But here it is given that your f of x is defined as it is a minus your modulus of x. If x is less than a, so this implies, I have already taught you, this is minus a less than x less than a, and is equal to 0 if modulus x greater than a. This implies that it is minus x, x is less than a and x is greater than a. That means what? Here minus a, here plus a, here only the function is defined, below minus a it is not defined, more than plus a it is not defined. So this means that the function is 0. The function is 0 below minus a and the function is 0 above plus a, and that it is defined in between this, and this is how it is defined. Okay, now let me come to this. So with this idea, so what is that you will write here? f of x is equal to 1 by square root of 2 pi. It is minus infinity to plus infinity. What is your f of x? So your f of x is a minus modulus of x into e to the power of isx dx. I have simply substituted the value of f of x in this place. So this is nothing but, as I told you, this one. So here this is this, here I will write only f of x. I will write only f of x. I will write only f of x. Here I will tell you the reason why I should. Because if you put this this, then your limit must change. So I am not using that. So you see that every step has got a meaning. If you're without a meaning, you cannot write a step. And there must be a logic, there must be a reasoning, everything must be there if you write the steps one after the other. So you see that this I cannot write because f of x I do not know. It is still in minus infinity to plus infinity. Now this f of x is defined only in this. So when you write this, you must write this as, so this as 1 by 2 pi. It is, no, it is not minus infinity. Actually this is minus a to plus a. And you must understand that this is minus infinity to plus infinity and this is minus a to plus a. And this minus a to plus a is a subset of minus infinity to plus infinity. It is a subset of that, and sometimes it may so see a is an arbitrary, so it can also be, you can think it to be defined from minus in, so there is nothing wrong. So but it is specifically given that your x is lying between 2 points, minus a to plus a. So keep this in mind, and that, so in this particular interval only it is defined. So this is equal to what? It is a minus modulus of x into e to the power of isx into dx. So this is what we have here. Now let me come to this. See, whenever you come across like this, you just take this. See, this is an art of doing. So you practice it, you will get. Otherwise you have to, necessarily there should be a mathematical brain must be there, but above all that, it a practice or practicing the problems may give you an idea to approach the problem. So it will make you conversant to approach a problem. So you see that I take this, now I can write in this place 1 by square root of 2 pi. It is minus a to plus a minus modulus of x into, I write this as cos sx plus I sin sx into dx. You have to write each and every step. So this is equal to what? 1 by square root of 2 pi into, I will write everything here, minus a to plus a minus square root modulus of that into cos x into dx plus, it is minus a to plus a, it is a minus modulus of x into I is there, I sin sx dx. So this is what you have here. Now you can go for a lengthy discussion and on this, but understand, if you can understand, you can just briefly explain and pass on to the next step. What I mean is that here you see that this modulus of x, even if you put minus x, it is plus x. Plus x means it's plus x. Even if you put minus x, this is going to be x only. That is, modulus of x is x for whether x is minus or plus. So take it right. Cos sx, if you change x to minus x, it will be cos x only. So this is an even function. And see, for example, you take this. See, you take only this. So what is this equal to? A minus mod x into cos sx. Now wherever, so you call this as some xi x. So what is your xi of minus x? So wherever x comes, you put it as minus x. A modulus of minus x of modulus is again modulus of x only into cos of s of minus x. But this cos of minus theta is again cos theta only. So a minus of this into cos x. So you see that psi of x is equal to psi of minus x. It means that this function is an even function. This is an even function. And you will see that this is an odd function. This is an odd function. This is an even function. So you see why this is an odd function? Because you see that modulus of x is even, it will remain, whereas the sin sx will be minus. If you change x to minus x, this will become minus sin sx. So this is an odd function. So whenever it is an odd function, we know that minus a to plus a of sin sx dx will be equal to 0. So you see that this is a property of the definite integrals. So this will become 0. So you are left with what? So I'll write here. So you are left with, see, f of x is equal to, so only this remains, 1 by square root of 2 pi, it is minus a to plus a, and it is a minus modulus of x into cos sx dx. So you are left with only this integral, because this becomes 0. So you are left only with this integral. Now what is that you must do? Just go ahead doing the problem. That's all. It is going to be a mere ordinary integration you have to do. Now what is that you find? Now you see that since this is an even function, we know that by the property of the definite integrals, it is 1 by square root of 2 pi into 2 0 to a minus x into cos sx dx. So this is what you get as what? This is the this is what you get for your this one. So because we know that by using the definite integrals, property of the definite integrals, we get this. Now you write this. What is that you will get here now? Now this is equal to, so this is equal to, it is a minus x. So you see that what will happen to this now? So I will write this. It is 2 by pi. Simplify, you will get, it is 0 to a you can write this as a cos x, a minus cos x. What is the integral of a minus cos x? A minus x cos x will be, see, it will be like this. You can write like this, a minus x into d of sine sx, sine sx by s. So using Bernoulli's method of integration, so what is that you will get now? Using Bernoulli's method of integration, so what is that you will get here now? So this is equal to, it is 2 by pi into, it is a minus x into sine sx by s, minus, differentiate this, 0 minus 1 into integration of sine x is minus cos sx divided by s squared. Put it like this and raise it to 0 to a. Raise it to 0 to a. Now what is that you will get here now? So 2 by pi square root of this. When you put this a here, a minus a is 0. So this whole thing will become 0. When you put a here, this is x. Minus into, see, this is minus. Minus into minus is plus. Then this is minus. So it is minus. When you put a here, it is minus cos ax as by s square. Put x is equal to a. Then minus, use the second limit. See, if you use the second limit, this is 0, sine 0 is 0. Don't worry about this. And you see that this is minus into minus plus. It is minus, so you are getting this one, minus. So this is minus of, you put 0 here. So here, if you put 0 here, 1 by s squared. So you will get what? It is 1 by s squared. This is minus into minus here. Minus into minus is plus. Then if you put, this is 1 by s squared. So this is what you will get. So I have not done anything. See, I put this, first apply this a, it will be 0. This is minus into minus plus minus. So it is cos as divided by s squared. Then minus, put 0, sine 0 is 0, don't worry. Minus, so you see that when you take this minus, if you apply the second limit, it will be what? This is 0. So you will get this to be, second limit, if you apply this, it is minus into minus is plus. Minus, and it will be plus. See, you just see that you apply the first limit here. I will, in fact, I'll write this as, I'll put it as, I'll write one more step so that we may not go wrong. So this is equal to 2 by pi into a minus x sine sx by s minus cos sx by s square 0 to a. Now this is okay. Now you see that when you put the, apply the limits, 2 by pi, it is, when you put a, it is 0. When you put this, it is minus cos as divided by s squared. Then put a minus, sine 0 is 0. When you put this, it is minus, yes, when you put 0 here, this is 0 minus 1 by s squared. So this is equal to 2 by pi into 1 by s squared minus cos as divided by s squared. So this is equal to 2 by pi into 1 minus cos as divided by s squared. That is equal to 2 by pi. What is 1 minus cos as? Your 1 minus cos as is, see, we know that it is the formula, it is cos, see, it is like this, that is cos as is equal to, see, it is, we can write this as 1 minus 2 sine squared as by 2. So 2 sine squared as by 2, it is 1 minus cos as. So I am using the formula cos 2x is equal to 1 minus sine squared x. So cos as is equal to 1 minus sine squared as by 2. So the value of 2 sine squared as by 2 is equal to 1 minus cos as by 2. So this can be written as, see, this is written as, so this is into 2 sine squared as by 2 divided by s squared. So what is the answer that you get for this? So your f of x will be equal to, so your f of x will be equal to f of x is your f of s is equal to, it is 2 into 2 by pi square root of this into sine squared as by 2 divided by s squared. This is what we get. So you see that this is the Fourier transform of this particular function, this one, f of x is equal to so much, a minus root of x. This is a function that is given to me. So I am able to get this result. Now this is what we get. Now what is that we want? So this is my Fourier transform. This is my Fourier transform. And now what is that we must do here is, we must get the, we have to prove this result. We have to prove this result. Now let us start proving this. Now therefore this f of x has been got. Now let us take the Fourier inverse transform. Let us take Fourier inverse transform for f of s. Here this one, call this as 2. So what is that you will get here? F minus 1 of f of s, which is nothing but your f of x. What is the formula here? It is 1 by square root of 2 pi into minus infinity to plus infinity f of s into e to the power of minus isx into dx. So this is what we get. So actually speaking, I will write here so that you will understand. So I will put it in this form. So this is nothing but your this is your f of x. This is your f of x. That is, what will you get for this? Slowly you do this, you will get the answer. So that is 1 by square root of 2 pi. It is minus infinity to plus infinity. In the place of this you put 2 into 2 by pi square root of this into, what is that you will get here? Sine squared as by 2 divided by, because I have taken this 2 of this thing, it's by 2 into e to the power of isx minus isx into ds. So this is equal to your f of x. Now you see that that is 2 by pi. If you take this root 2 will go off, giving you 2 by pi. 2 by pi, it is minus infinity to plus infinity. It is sine squared as by 2 divided by sine x squared into, I will write this as cos sx minus I sine sx into ds is equal to my f of x. Now you see that this is, if you do this sine squared, if we split this into two integrals, sine squared as by 2 divided by s squared into cos x into ds, sine squared as by 2 divided by s squared minus I. So when you multiply this and this is an even function, this is also an even function, because sine squared is an even function, s squared is an even function, whereas this will be an odd function. So you see that this will be 0. Whereas here this is a cos function, so you will be left only with this. I will write here, that is 2 by pi. Okay, now this is minus infinity to plus infinity. It is sine squared as by 2 divided by s squared into cos sx dx plus 0 is equal to f of x. Because I told you that this sine squared into this will be an odd function, because so for this reason only, the reason is integral of, or see, it is since this one, no, since sine squared, say I can write this sine squared as by 2 divided by sine squared into sine ai sine sx is odd. So because this is an odd function, this becomes 0. Now let me write this now. So what is that you will get here now? So you will get this to be, so this is nothing but 2 by pi. It is, so you will get this, you will get 2 pi. See, it is not this 2 by pi, 2 and 2 will go off, pi 2 by pi. It is not square root of this, it is 2 by pi. So it is 2 by pi minus, it is 0 to infinity, because using the properties of integrals, definite integrals, 0 to infinity of sine squared as by 2 divided by s squared into cos sx ds is equal to f of x. F of x, actually speaking, this is equal to, you know, it is a minus square root of square, this one, in minus it is between minus a less than x less than plus a, and is equal to 0 for what? X greater than, x less than, x greater than a, and x is less than minus a. Below minus a it is 0, above plus a it is 0, only for this interval. So don't bother about this, you will get. So this is equal to your f of x. So f of x will take either this or this. This will not come, only this can come. So what is that you will get here? What are you asked to get the value? Sine squared t. So you see that, take as okay, as, see here you have got here as by 2. So let me take, this is what is that you will get here, 4 by pi 0 to infinity sine squared as by 2 divided by s squared into cos sx into ds is equal to, here I will take this, so f of x, f of x. You can take this one. Now, here if you take see, we will take x is equal to 0 because x is a point of continuity and it lies between minus a to plus a, because I have to prove this result, get this result. So you can take this x to be 0 because cos 0 is 1, and moreover this cos is a point in minus a to plus a and it is a point of continuity. Take x is equal to 0, which is a point of continuity in minus a less than x less than a, and f of 0. What is your f of 0 here? If you put f of 0, it is 0, so f of a is equal to 0. F of 0 is equal to a. Therefore, I'll write here 0 to infinity, it is sine squared as by 2 divided by s squared into this becomes 1. So ds is equal to, it is pi by 4 into a, that is pi a by 4. Pi a by 4. You get this pi a by 4. Now let me take this. See, I will call this as by, now I want it in this form. So what I will do is, I will take this, let as by 2 be equal to your t. So when s is, see here the variable is s. S is equal to 0 implies t is equal to 0. S is equal to t implies t is equal to infinity. And a by 2 into ds is equal to dt. So this implies dt is equal to 2 dt by a. So I go for a change of, because you see that I want here sin t here. So you see that I am getting here. So you see that I change this as by 2 is equal to t, so that this will come. Now I will change this everything here. So what is that you will get here? So therefore 0 to infinity, it is sine squared t divided by, what is your s? S is equal to 2t by a, and s squared will be equal to, so this is 4 by a t squared into, what is this dt? See, dt is ds, here your ds is 2 by a, so this is 2 by a into dt is equal to your, see here I got here pi a by 4. So this is what we have. So I'll write here. So this is what you will have here. So this is, that is, this implies 0 to infinity sine square t by t squared into a by 4 into 2 by a into dt is equal to pi a by 4. I am taking this on top. So a by 4, so this and this will go off, this and this will go off 2 times, and you see that what is that you will get here now. So this one, that is 0 to infinity of sine t divided by t whole square into dt is equal to, it is 2 pi a by 4, that is equal to pi by 2 into a. Now this one, no. See, actually you have to prove that this is equal to pi by 2. See, we have got the result here. That is 0 to infinity of sin t by t whole square dt is equal to 2 pi a, pi by 2 into a. See, this a, pi by 2 into a, but it is a is taken to be 1. Because you see that after all this a is an arbitrary point. I told you that this is minus infinity. It is like this, minus a to plus a. It is minus infinity to plus infinity. This minus a to plus a is after all a subset of this minus infinity to plus infinity, and this a is after all a arbitrary point. You can even take 2 or you can take 3, whatever you want you can take. So from the answer that is given to me, I feel that a must be taken as 1. Are you able to understand what I take? A is equal to 1. Why we take a is equal to 1? Take a is equal to 1. I take a is equal to 1 because a happens to be an arbitrary point on the, because this Fourier transform is valid for the whole of the real line minus infinity to plus infinity. So it is applicable to minus a to plus a, whatever be a. And so I take, for my convenience, a is equal to 1. You can take any value. Even if you want, you can take 2 also, no problem. So you see that this is valid for all points. So take a is equal to 1. So take a is equal to 1. Take a is equal to 1. Then 0 to infinity of sin t divided by t whole square dt is equal to pi by 2 into 1 is equal to. So this is how we do this. So here what is required of you is that write the Fourier transform, patiently do the integration, and use the idea of odd and even function, and use the property of the definite integrals and arrive at the Fourier transform. After finding the Fourier transform, you try to find out the Fourier inverse transform. And that Fourier inverse transform means what? Coming back to the function f of x in the x plane. So you see that what is f of x? You try to find out, and you are given the interval where this f of x is defined. From which place you can decide what, so you can decide about f of x taking the value. Here you see that f of x will take a minus root of modulus of x, because in other places it is 0. Then after getting this, you take x is equal to 0, because x is equal to 0 is a point lying between what? Minus a to plus a, and it is a point of continuity. Because I understand everything from the answer given in the problem. This one tells me that take take x is equal to 0. So when I take x is equal to 0, cos 0 is 1. So conveniently that I am able to overcome that difficulty. After then, you see that you substitute, go for substitution and bring it to the form sin t by t. Sin square t by t squared, and you take a is equal to what? 1, because you can take a is equal to 1 because after all a is an arbitrary point. It is an interval a minus a to plus a is an arbitrary interval. It is true for all values of n. A that here you can take, that is without loss of generality, you can take a is equal to 1, so that you will get this answer. So this is an important problem. This may be a problem in your university exam also. Take care of this and practice. We will do more problems on this. This is my Fourier transform lecture 2. FT lecture 2. Okay, thank you.